Hello and welcome to Chapter 2.1 from Stevens' Introduction to Statistics, the Think and Do book. In this chapter we're going to talk about averages. And even if you have not had a statistics class in your history, you probably have heard of these averages. You've probably studied them in some course somewhere, maybe in middle school or high school. And the three averages we'll discuss are the mean, the median, and the mode. Right, and hopefully you have some familiarity with these, but if you don't, that's fine. We're going to go over them in detail here, and even if you do, you should probably tune in because there's some terminology and a few little things that you may not recall or be aware of. Okay, so these are all averages. They are measures of central tendency. It's a single number to describe a set of data, sort of the middle of the set of data, or the average of the set of data. And for these demonstrations, we'll use this sample data right here. There are 6 numbers, and we're going to find the average. We're going to find the mean, median, and mode of those 6 numbers. And so the mean, this is probably what you would have done if I had said, find the average of those 6 numbers. You would add them all together and divide by how many there are. All right? And when you add up those numbers, you get 10.9. There are 6 of them, so you divide by 6, and you get 1.82. So that's the mean, or the arithmetic mean. I'll just be calling it the mean. And it's worth paying attention to some notation here, because this notation is used throughout the entire textbook. So when you look at this formula, you added up all the values and divided by how many there are. Here is the way we would write that in formulaic notation. X bar, that's the sample mean, right? It is the sum, this sigma right here, this capital Greek sigma. That means you're going to add things up. So sigma means you add things up. And in this case, we're going to add up all of the x's, all of the individual values from the data set. So this says add up all the values from the data set, divide by the number of elements in the data set, right? It's called X bar when we're talking about a sample, and the same formula is given here. It's denoted mu. It looks like a U. It rhymes with U, but it is actually the Greek letter mu. And again, you're adding up all the values and you're dividing by how many you have. So the process is identical. The notation is a little bit different. Okay, so that's getting the mean. The median is the middle value when the data is ordered from lowest to highest. So the first thing you have to do is remember to order the data from the lowest to highest and then pick the middle value. And that's great. If there's an odd number of values, there actually is a middle value. If there's an even number of values, then there is no middle term. You have to take the 2 middle terms and average them. So when you look at our numbers from our sample up here, they're not in order, so we have to order these, right? And when we do order them from lowest to largest, we get this same set, ordered smallest to biggest. Since there's 6 of these values, there is no middle term, but there's a middle 2, 1.1 and 1.8. So when we have 2 middle terms, we're going to average them, and we're going to take the mean of the 2 middle ones. So when we average 1.1 and 1.8, we add them together, divide by 2, and we get 1.45. So the median of this data set is 1.45. Sorry, I had trouble putting a box around it. Still having trouble. My pen. How about I'll just underline it? My marker is going above. There, okay. All right. So the median is 1.45. Mean 1.82, median 1.45. The mode is the value that occurs most frequently, right? For our example up here, look at our data, everything occurs once except for 1.8, right? We have 2 of those, so our mode is 1.8. Had we not had to, suppose this was a 1.3, suddenly there wouldn't be a mode, right? And we'd call that no mode. And if we had two modes, it would be called bimodal if there's a tie for the most frequently occurring value. You'd have two modes, and that's called bimodal, and when you have more than two modes, it's called multimodal. Right? And when there is no repeated value, you get no mode. But we did have a repeat, 1.8, so our mode is 1.8 for this data set. Okay, rounding, and this is a process worth remembering because it's used in other sections as well. When you're calculating the average, it uses a mean, specifically the mean, obviously, and sometimes the median, whenever you have that two middle terms and you have to average them. We're actually taking the mean of the two middle terms. So anytime you're using the mean to get an average, you want to round your answer to one more decimal place than is present in the original data set. Right, so one extra decimal. And the reason for that is, suppose you only have two numbers. Suppose you have the number 2 and the number 3. If I said, what is the average of 2 and 3, you'd probably say 2.5. And that would be correct. And you don't want to round that to 2 or 3 because you don't want to say, oh, the average of 2 and 3 is 3. Right? That's crazy talk. So you go to one more decimal place than is present in the data. And in this case, for our data in the example, there was no decimal places, right? They were whole numbers. Oh no, sorry. They weren't whole numbers. They had one decimal place. And so when we rounded the answer for the mean, we went to 2 decimal places, right? The data is 1 decimal place, and the mean 2 decimal places. Always one more than the raw data. Right? Okay, so that's the rounding rule. The term average can be used for any of these means or any of these averages, such as the mean, median, or mode. But if I use it, I will be talking about the mean. And usually when you hear it, and even in software, average is the mean. Usually if someone is quoting the median, they'll just use the word median. And mode is not used often enough, but if the mode is being used, they should use the word mode, as should you, as will I. The mean, median, the mode do not always produce the same value, right, as our previous example demonstrated. The mode was 1.8, the median was 1.5, and the median was 1.82. And here's the difference between these, right? So the difference is, suppose I change one of these values. I'm going to change this 4.9 to, say, a 25. If that 4.9 is changed to a 25, the mean is going to go up drastically, right? The mean is sensitive to extreme values, whereas the median will not be affected at all. So the median is not affected by extreme values. And that's what these two bullet points say here, right down here. The mean is sensitive to extreme values, the median is not. And the mode is not used very often, but it is used for non-numeric data. All right, so we come to some sample data here, your turn. So we have 5, 8, 11, 12, and 13. And I want you to calculate the mean, the median, and the mode. Right? So the mean, let me put it's called sample data, so I'm going to find the sample mean, which is, the formula is the same, but I'm just using slightly different notation. It's the sum of the x's over the sample size, right? And so when you add up all the x's, you get 5 plus 8 plus 11 plus 12 plus 13 all over, and there are 5 of these, right? See, 25, 36, 44, 49 over 5, right? And what that gives me, whenever you plug that into your calculator, is 9.8, right? So the mean is 9.8. I'm rounding to one more decimal place than the raw data. So I get a mean of 9.8. The median, the nice thing about this data set is it's already ordered from smallest to largest, and it's an odd number of values. So it's just the middle term. So it's 11. And the mode, if you look at that, none of the numbers are repeated, so there is no mode. All right. All right. So now, in this next little set of problems, I say without recalculating the averages, right? I don't want you to redo the math. Describe what would happen to the mean, median, and mode if the following changes were made. All right. So for part A, suppose the 13 was changed to a 23. So what I'm saying is, suppose this 13 was not a 13, but rather a 23. Well, if you look at that, the sum of all the x's is going to get much bigger, and the mean is going to increase. Right? So the mean will increase. The median is still going to be 11, right? So there's no change in the median. No change in the median. And the mode, there is still no mode. So still no mode. Right? So notice the mean was affected by this extreme value, but the median was not. So for B, suppose the 5 was changed to a 3 and the 13 to a 15. So this 5 is going to go down by 2 to 3, and this 13 is going to go up by 2 to 15. In that case, the mean will actually be the same, because when you add up all the x's, you lost 2 here, but you gained 2 over here. So whenever you add up all those x's, it's still going to add up to the same. And so your mean is not going to be changed. Right? And the median will still be 11, and there will still be no mode. Right? So in that case, nothing changes. Right? None of these change. All right? The mean, the median, the mode all stay the same. And for C, suppose the 11 was changed to an 8. So I'll go back to my original set here. Suppose my 11 was now an 8. Right? Well, one thing we're sure, the mean will go down, because my sum of the x values, the sum of the terms, will be smaller, so the mean will go down. Right? So the mean decreases. The mean decreases. What happens to the median? Well, if you take a look at this, the median is now 8. It's no longer 11. Remember, when you're ordering these for the median, if there's doubles, you count each, you count it twice. You put 2 8s down there when you're putting them in order. When you do that, the median is now 8. All right, so the median is now 8. And the mode, all of a sudden, now I have 2 8s. And so I do have a mode, and there's a mode of 8. And so the mode equals 8. So it goes from no mode to a mode of 8. Right. So, and you don't necessarily have to recalculate all these things to know how these changes are going to take place. Loosely speaking, a normal distribution, or normally distributed data, and we'll slowly refine this definition to be more and more specific. But for right now, loosely speaking, most of the data values, most of the entries are bunched around the mean. All right, you get a lot of data values near the mean, with fewer entries farther away from the mean. And specifically, the mean and the median and the mode will all be about the same. Right? So the data will be pretty much centered, right? Because the median gives you the center. It will be centered on the mean, and that will also be the most frequently occurring value. Right? So that, for now, is what we mean by a normally distributed data set. In practice, if you were calculating the mean, median, or the mode, you'd probably do that. If you had more than a dozen numbers or so, you'd probably do that with software. Any statistical software will do that for you. Graphing calculators will do that for you. But for the example problems in the book, the number of data elements will be small, so doing it by hand is not particularly cumbersome. But if you get more than a handful of numbers, you probably want to use software. And demonstrations for how to calculate averages with various software is given at stevenstats.com. We have Excel, SPSS, Minitab, and the TIs. So if you need to do that with software, you can go to that website and check out some demonstrations. Some of them are video, some of them are paper. All right, so that wraps up Chapter 2.1, Averages. In the next section, we will look at measures of variation. Right? But for averages, we're good. I'll see you in the next section.